We now want to spend a little bit of time talking about inequalities. So we've mostly been focused on equations, right? Where we have something like, maybe like 5x plus 3 equals 5 or something like that. Or in the context of a function, right? F of x equals 5x plus 3, maybe something like this. So for solving an equation, we have our normal equation solving steps. We can do pretty much anything we want to the equation as long as we do it to both sides. So here we might get 5x equals 2, divide by 5 and get x equals 2/5. So when we talk about solving inequalities, we're going to be following basically these same steps, but there's going to be some key rules that we're going to have to keep in mind. So the context that we usually will see this kind of thing would be, say we have the function, maybe just something like x plus square root of x plus 2. When we go to find the domain of this function, we have to look at, okay, where is x plus 2 greater than or equal to 0, right? And then we would solve this inequality, and we get x is greater than or equal to -2. And we would just get that by just subtracting 2 from both sides. So it's often coming up in like a domain context. But there's lots of ones that get a lot trickier than this. Like if we have the absolute value of x plus 2 is less than or equal to 2 or something like that, like there's going to be more steps involved. Or we can have something like x squared plus 4x plus 5 is greater than or equal to 3 or something like this. So there's a lot of variations on this that can introduce a lot of different steps that we need to consider. So we're going to start by focusing on the linear inequalities. So just stuff like this. And then we're going to spend some time looking at absolute value inequalities. And then later on, as we get to other types of functions, like when we look at quadratics specifically, at that point, then we'll look at inequalities with the quadratics. That's what the x squared functions are called. So we'll kind of add them on as we go throughout the course. So first, let's just go ahead and look at the basic rules of linear inequalities. So in other words, these are going to be things where you have like a straight line, right? So we just saw x plus 2 is greater than or equal to 0. That's when x is greater than or equal to -2. So let me show you a little bit about what's going on graphically here. Okay. If we think about the equation f of x equals x plus 2, this is a line with slope 1, y-intercept 2. So it's going to look roughly like this. So notice it's crossing the x-axis at x equals -2. Okay, this point right here. So this is telling us that the function, the f of x values are greater than or equal to 0 when x is greater than or equal to -2, right? Which we can see graphically here, right? The y values are positive when the x values are greater than or equal to -2. And then on the flip side, once you go past -2, everything is negative. So this is a really important concept. Okay, so if we let's just do a couple other ones, like maybe x minus 3 is, let's do less than or equal to 5 this time. Okay, well, we can add 3 to both sides, and then we'll get x is less than or equal to 8. Okay, so again, if we graph this one, maybe I should change the color here. If I graph f of x equals x minus 3, this is a y-intercept of -3, again, slope of 1. Then you can see it's less than or equal to 5 when x is less than or equal to 8. So we're hand drawing it, so the x values aren't exact here, but we can imagine that f of x being 5 corresponds somewhere to like x being 8. So it's beneath that line of y equals 5 when x is to the left of this line, right? The x equals 8. Okay, so this is what it's telling us. And a lot of times we like to think of this like kind of by moving everything towards 0. So like visually, so like what I mean by that, and this will come into play a lot in like the nonlinear inequalities, is that we'll look at x minus 3 minus 5 is less than or equal to 0. So we'll bring the 5 to the other side, and we'll look at when x minus 8 is less than or equal to 0, right? So this is going to be when x is less than or equal to 8. So in other words, what we're doing with this line is that we're taking it and we're moving it down 5. And we're looking instead, okay, now that we moved it down 5, we want to look at where is it less than or equal to 0. And it's going to give us those same values, right? The same values where x is less than or equal to 8. So it's an equivalent problem. It just, we move everything towards 0. And like I said, it'll be more common in the nonlinear inequalities because it's more convenient for us to solve those problems when they're equal to 0. Okay. So let's do one where maybe our coefficient isn't 1 this time. 2x plus 4 is greater than 5, maybe. And by the way, a lot of times we like to write these answers with interval notation. So maybe we should do that here. So like this one, for example, the answer would be -2 to infinity, including -2 because we do have the equal part in there. This one would be -infinity to 8, again because 8 is included, so we include it on the with the bracket there. Okay, so now going down to this one, so we do the same steps we would for a regular equation. Okay, so we get 2x is greater than 1, and then we divide both sides by 2. So x is greater than 1/2. Okay. So, and that's our answer. So in a lot of cases, it's just as simple as solving a regular equation is. So here our answer is going to be 1/2 not included because we don't have that equal sign to infinity. Okay. Now we do have to really pay attention to when we have a negative on the coefficient of the x. Okay. Let me use the space over here, I guess. Let's just think about just negative x is greater than or equal to 0. Okay. Negative x is greater than or equal to 0. Then that means that the x values must be negative, right? The numbers we're putting in for x, because it needs to cancel out the negative right here. In other words, like if I put in -2, then I'm going to get 2, which fits the inequality, right? It makes it true. And same with if I put in -3, -4, etc. So we know that the answers here must be the negative numbers, right? In other words, anything less than or equal to 0. So it might look a little strange if we use our normal equation solving techniques, right? If I divide both sides by -1 and just leave it as is, well, it doesn't really make sense based on this, right? If we go back and test a number, like if I test, okay, x is greater than or equal to 0, so say x is 2. Does that make sense? Well, in the original, it doesn't make sense, right? Because then that's saying -2 is greater than or equal to 0, which we know is false. So what's happening here is when we're dividing by a negative, we need to flip the sign in order to account for this discrepancy. Okay, and same thing with multiplying by a negative, because again, multiplication and division are, really the same umbrella of operation. So when we're multiplying or dividing by a negative, we need to flip the sign in order to maintain the inequality. Okay, so that's really important because, we'll divide by a negative number a lot, but also this will come up if we're dividing both sides by a variable. We need to think, okay, is that variable going to be negative or is it always going to be positive, right? So this is kind of the key to inequalities, is that we really have to consider all of these cases. Okay, so anyway, we end up with x is less than or equal to 0, so negative infinity to 0. So if we think about another one like negative 3x minus 7 is less than 14. Okay, so we add 7 to both sides. We get negative 3x is less than 21. And now we divide both sides by negative 3, meaning that we need to flip the sign. Okay, so x is less than becomes x is greater than, and then this one's going to be negative 7. So we get that x has to be greater than negative 7. Okay, and when you're doing these and you're like keeping track of the sign flips and stuff, it's never a bad idea to test one of your numbers, see if it makes sense. Okay. Like an easy number here is 0, right? 0 is greater than negative 7. So does 0 work in that original equation? If we put 0 in here, we get negative 7 is less than 14, and it works, right? It makes sense. So we can see that, yeah, this does seem like it makes sense. So negative 7 to infinity would be our answer here. Okay, now if we think about 4x plus 7 is greater than or equal to 2x minus 3. So now we have a variable on both sides, but that's not going to change anything, right? We're just going to have more steps. So we'll bring all the variables to one side. Bring all the numbers to one side. Negative 10. Right, and then divide both sides by 2. So we get x is greater than or equal to negative 5. Okay, so don't be confused by the negative on the right side, right? It's only if we're dividing by a negative or multiplying by a negative that we would need to flip the sign. Okay, so we get x is greater than negative 5. I like this one because, these are like two different lines, linear functions, and it's kind of like we're comparing them. Like if we think about this graphically, right? Like if we think about 4x plus 7, actually this would be a great one to look at on the graphing calculator. Let me switch over to that. So you can see on this one here, I went ahead and I graphed the functions 4x plus 7 and 2x minus 3. So the 4x plus 7 is the red line. So the question was asking us, where is 4x plus 7 greater than or equal to 2x minus 3? And we got the answer, x is greater than negative 5, greater than or equal to negative 5. And we can see on the graph here that at x equals negative 5, that's exactly when the red line starts being larger than the blue line, right? That's where the output values are larger. It's above the blue line. So I think this is a great way, we often kind of neglect like thinking about this graphically in the inequality context, but I think this is a great way to visualize these, to throw both sides on a graph and, see what the which one of them are larger. So just going back to one of them, like when we did x minus 3 is less than or equal to 5, we can even do that on here. Okay, you have to actually put y equals 5 in here for that to come up, but you can see even that, it's like looking at the lines x minus 3 and the lines y equals 5 and seeing, okay, when is the red line smaller, in other words, lower than the blue line, right? And it happens exactly here at x equals 8. That's when the transition happens. So for all these inequalities and really just anything we do in this course, like with function stuff, it's really helpful to just throw them in a graphing calculator first, just so you can kind of visualize exactly what it is we're doing.